look at functions, what they are, and how we can use them. A function is simply a rule that assigns a unique output to every input. We give an input, a rule is applied, and then a unique output is obtained. The inputs are elements x from some set A, which is known as the domain. So we represent the inputs by something like the letter x. The outputs are elements, typically denoted by f of x for a function f, of a set B. These are known as the range. So the inputs are the domain, the outputs make up the range. What really defines a function is that every input has only one output. Anything that you put into the function will give only one output from the function. Let's consider the function f of x equal to 2x squared minus 1. The first thing we need to do to evaluate this function to perform this rule is to square the input. Once we've squared the input, we're going to take that answer and multiply by 2. And finally, after we multiply by 2, we'll subtract 1. And this will give us the output. Once we square the input, multiply by 2, and subtract 1, we have the output. So this is essentially the rule that defines the function in words. Let's look at something like f of 1. What this says is what is the output when 1 is the input. So all it's saying is that we need to change x to a 1. So we have 2 times 1 squared minus 1. 2 times 1 times 1 is 2. And 2 minus 1 is 1. So for this function, when we input the number 1, we get the number 1 as an output. Next, let's look at f of negative 2. In this case, we have 2 times negative 2 squared minus 1. 2 times negative 2 times negative 2 is 8. And when I subtract 1, I get 7. So when we input a value of negative 2, we output a value of 7. Next, let's look at something like f of the square root of 3. In this case, we change the x, or the input, to square root of 3. 2 times the square root of 3 times the square root of 3 is 6. And when we subtract 1, we get 5. So for this one, I used square root of 3 as an input and got 5 as an output. Let's consider the domain of this function. This is essentially asking what kind of inputs are allowed. And we can stick in any number for x that we want, and we will get a valid input. So the domain is all real numbers. Sometimes we write this as the interval from negative infinity to infinity. Or we can write it with this R symbol that represents all real numbers. The range, on the other hand, these are the outputs that we get. And we can't get any number out of this function. To make x squared as small as possible, we would have to input 0. And 2 times 0 squared minus 1 is negative 1. And it's impossible to make this function any smaller. Inputting in any positive numbers is going to make x squared positive, and inputting any negative numbers is going to make x squared positive. So inputting 0 is the lowest possible output. So this says the range says that f of x will be bigger than or equal to negative 1. In interval notation, we would write negative 1 with a square bracket. comma, infinity. Let's look at a couple more examples using this function. Let's start with f of negative 3. We would have negative 3 squared minus 3 times negative 3 plus 1. I would change all of the x's to negative 3. Negative 3 squared is 9. Negative 3 times negative 3 is 9. Plus 1. And 9 plus 9 plus 1 is 19. So inputting negative 3 outputs 19. We could look at f of 0. This would be 0 squared minus 3 times 0 plus 1. 0 squared is 0. Negative 3 times 0 is 0. Plus 1 gives me 1. In this case, when we input 0, we output 1. We could look at something like f of 2. This would give me 2 squared minus 3 times 2 plus 1. 2 squared is 4. Negative 3 times 2 is negative 6. Plus 1 gives negative 1. In this case, when we input 2, we output negative 1. We could also look at fractions. We could do something like f of 1/2. In this case, we have 1/2 squared minus 3 times 1/2 plus 1. 1/2 times 1/2 is 1/4 minus 3 over 2 plus 1. And if you simplify this, you get negative 1/4. So inputting 1/2 gives an output of negative 1/4. Inputs for functions also don't have to be constants. We can look at things like f of a. In this case, we would have a squared minus 3 times a plus 1. I would just change all the x's to a. If we looked at something like f of negative a, that would be negative a squared minus 3 times negative a plus 1. A negative times a negative is a positive, so this is a squared, and negative 3 times negative a would be positive 3a plus 1. So we can input variables as well, and we can even input expressions. We can find things like f of a plus h. In this case, we would have a plus h squared minus 3 times a plus h plus 1. If I FOIL a plus h times a plus h, I would get a squared plus 2ah plus h squared. If I distribute my next parenthesis, I have negative 3a minus 3h plus 1. And we can even look at things more complicated than that. If we look at something like f of a plus h minus f of a over h, provided h is not equal to 0. F of a plus h we just found. That was a squared plus 2ah plus h squared minus 3a minus 3h plus 1 minus f of a, which we also found to be a squared minus 3a plus 1 over h. If we simplify this a little bit, we have a squared plus 2ah plus h squared minus 3a minus 3h plus 1. Distributing my negative sign says minus a squared plus 3a plus 1 all over h. We can then start canceling. We have a squared minus a squared. We have minus 3a plus 3a. And this should be a minus 1 when I distribute that negative sign. And we have plus 1 minus 1. So this simplifies to 2ah plus h squared minus 3h over h. We can notice there's an h in common in the numerator. That leaves us with 2a plus h minus 3 over h. And since h divided by h is 1, that leaves us with 2a plus h minus 3.
If you would like to see Professor Pierce make more videos like this one, you can support her on Patreon in the link below. Any and all support means a lot to her. It allows her not only to make more videos, but it also allows her to campaign for free and accessible online education to conferences and other universities. Thank you for watching, and remember, math is for everyone.